just this rectangular grid may be used to plot points given by a rectangular coordinate, such as point -3, 1. Here it is, -3, 1, or 1 with coordinate point with coordinate 1 and 2. So a grid consisting of concentric circles with center at the pole. Here it is, the pole. And rays can be used for polar coordinates. For example, polar coordinates, in the system of polar coordinate, the point with coordinate 4 and 5 pi over 4, or point in polar coordinate with the point with the coordinate 2 and pi over 4. Okay, so let's identify and graph polar equations now by converting two rectangular equations, because it's easier to work like that. So we have question number 1. We have r is equal 3. So we know the formula, since we are working in polar system of coordinate, which represent concentric circles. So let's write down the formula for the circle, which is x squared plus y squared equal r squared. R at x and y, those are coordinates of circle, center of circle, and r is a radius, where in the polar circle it's also represented as a radius r, distance, or now we can call it a radius. Okay, so therefore I can write down x squared plus y squared is equal r squared. Here in this case it's going to be equal 9. So the graph of r is equal 3. Here you have, so we have first concentric, second one, length is which is a length of the, here it is, 3, see? And the third one, the length of the third concentric circle gives you the radius 3. Okay, here also you can see radius 3. There we go. Okay, since we have a circle, right? X squared plus y squared equal 9. Therefore, it's going to be a concentric circle with radius 3. Okay, next one, question 2. What do we have? Identify and graph a polar equation. So, and that equation is going to be theta is equal pi over 3. Okay, so this piece, see, it's pi over 3. Let me provide a straight line. This is our pi over 3. So this is straightforward, but if we want to represent how it will look like in the rectangular system of coordinate, I'm going to take the tangent on both sides. Tangent theta is equal tangent pi over 3. Okay, and since tangent is nothing else but the opposite leg divided by adjacent leg, right? Opposite leg of tangent is going to be our y. Adjacent leg is going to be our x, right? So tangent theta is going to be y over x, right? And y over, and that is going to be equal, how much? Tangent pi over 3 is equal square root 3. Tangent 60 degrees, it's square root 3. And from here, we need to find y. Y is equal square root 3 times x. And this blue line, it's gonna be our graph. Okay? So the graph of theta equal pi over 3 is the line passing through the pole, this pole, making an angle of pi over 3 with the polar axis. Okay, next question, number 3. We are solving right now easy cases. We'll go more interesting cases after I cover this one. We'll start solving more interesting cases. So, identify and graph equation R sine theta is equal to. Okay, remember the formula that y is equal r sine theta and x was equal r cosine theta, correct? So since y is equal r sine theta, we can rewrite. So r sine theta we have here, r sine theta we have here. Therefore, we can write down that y is equal to. Yes? Once we write down y is equal to, it's gonna be the horizontal line. Here it is with distance 2. This is a first circle and this is a second circle, right? Distance is 2 and this is our r sine theta equal to, or we can write down on this end y is equal to. Okay, next one. Now let's do vertical line. Since we did horizontal, then we need to do horizontal line also. And in this case, guess what we're gonna do? R cosine theta. And as you can see, it's on the negative side of x, right? Is equal negative 3. So since we know that x is equal r cosine theta, right? Then we can write down that x is equal negative 3, correct? Therefore, the graph of r cosine theta equal negative 3 is a vertical line with 3 units to the left of the pole, which is here, 1, 2, and third one is where it's, so it looks like, well, no, it's not. I thought it looks like tangent line. Okay, well, maybe on the picture it touching, it should be only 1 point. Okay. Next one. Now this one is interesting. Question number 5. Identify and graph the equation r is equal 4 sine theta. Okay, so to graph the equation r is equal 4 sine theta, we need to transform the polar coordinate to rectangular. And we know that rectangular is equal x squared plus y squared is equal r squared. But we have r instead of r squared. So what we're gonna do, we need to multiply the entire equation by r. So r is equal 4 sine theta. And I'm going to multiply the entire equation by r. And we will get r squared, because we need r squared, right? R squared is equal 4r sine theta. Okay, so this is formula for circle, x squared plus y squared, r squared. It's a formula for a circle in rectangular coordinate. And from polar coordinate, we already know that y is equal r sine theta. So since we have 4r sine theta, then that means this piece, r sine theta, we can replace with y, correct? And we are going to get r squared. Hence, from here, we are getting r squared is equal 4y. Okay? Then let's replace into formula of circle. So we can write down x squared plus y squared is equal 4y. And then moving over for y, x squared plus y squared minus 4y is equal 0. So let's put this in parentheses because there are both y's. And what we are going to do, I'm going to complete till perfect square. Remember the formula for perfect square? A minus plus minus b squared. A plus minus b squared is equal a squared plus minus 2ab plus b squared. So what do we have here? We have x squared, and then here we have y squared. We need to have 4y. It has to be, this is 2ab, right? 2ab, which is twice 2 times y. So we have left there what? 2. So first term is the x is going to be as 2, right? 2 times y times 2, because 2ab, right? So when I multiply this 2ab, I have to get 4y. So 2 is a constant, y I took as an a, and b is going to be what is left, 2, right? We need to multiply by 2 to get 4y. So which means 2 is going to be my b, and that means I have to add, so minus 4y, and then I need to add 2 squared to complete to perfect square, and at the same time subtract, so I won't disbalance the equation, right? And this is equal 0. So from here I'm getting x squared plus y minus 2 squared, this is this piece, okay, minus 2 squared, and this minus 4 I'm putting here is equal 4. So, and what do we get? We are getting formula for circle where the center y is shifted by 2. Okay? Center y is shifted by 2. Here we have, let me move this piece. I don't know how much successfully I can move. I'll try. Okay, one more time. Okay, well, this one we can move up. All right, so we have it, and we are getting circle where y coordinate being shifted by 2. So y minus 2, here it is shifted by 2. Look here, 2 units, 1 or by radius by 2, 1 and 2, see? And radius is 4, which is going to be 2 squared, right? So the radius is going to be our 2, okay? So if you count it, look here, 2 units, 1 and 2, radius 2. If I come down, this is 1, this is second one. And this is our coordinate. So coordinate here is x and y minus 2. okay, with radius 2. Okay, solving next one. Question number 6. So what do we have here? We have r is equal, 1 second, okay, number 6, r is equal -2 cosine theta. Okay, so because we need r squared, okay, -2 cosine theta, and we need for our rectangular systems, formula for square is x squared plus y squared is equal r squared. And obviously we need to get r squared, and we have only r. Therefore, we are going to multiply by 2, right? And it's going to be equal, so r squared is equal -2r cosine theta. So we multiplied and left and right side by r to get r squared for the circle. And from here we have x squared plus y squared equal r squared, right? Where r squared is equal -2r theta. So, but we know that x is equal in the polar coordinate r cosine theta, which means if I replace r cosine theta, replace with x, I'm going to get -2x. Okay, let's rewrite x squared, moving over, getting 2 plus 2x plus y squared equal 0. Okay, the same way we are going to complete. Now this time we are going to complete x to perfect square. It's going to be x squared plus 2x, right? So 2 we are supposed to have it for perfect square, right? 2ab. This is 2, this is our ax, which means b, we completed already 2x, so for b it's going to be 1 left, okay? So we are doing plus 1, and not to this balance equation, doing -1 also, and plus y squared equals 0. And from here, this piece, it's going to be equal x plus 1 squared plus y squared is equal 1. Okay, so we completed the square, and here we have formula for circle. In this case, we have x is shifted. Look here. All right. Is shifted by 1, x plus 1, that we go towards -1, and it's by 1 unit. Shifted by 1 unit x, right? See that? And since the radius also 1, you see that's why circle is so small, because the radius is only 1. Okay. So tomorrow I will prepare video for testing polar equations for symmetry, because it makes our life easy. If graph is symmetric, when you build one side, the other side you can build automatically based on symmetry, right? So next video is going to be very interesting. We are going to graph a polar equation with the name, it's named cardioid, and then we will draw a polar equation with the name limacon with inner loop, and limacon with without inner loop, and finally we will learn how to graph the famous polar equation with the name rose. Okay, and there is another one I forgot to mention. It's lemniscate. Yeah. All right. So it's interesting video. It's gonna be tomorrow, and I hope you enjoy it. I like polar coordinate. It's kind of fun. It's something new, completely new, and it's interesting. So, okie dokie. The next this video it's gonna be tomorrow.